Alrighty, let's look at this next lesson in our quadratics unit. The do now here wants us to graph the following quadratic equation. So in order to do this, we are going to come over here to our graphing key, and we are going to type in what they want us to graph. They want us to graph y equals, which is already typed for us, x squared plus 8x plus 12. Very nice. Now we're going to click second graph, let's just get a picture of what our graph would look like. And let's look at the table. Alright, so let's see what we're going to be graphing here. Alright, I'm looking for all the numbers that are smaller than 10. So, I have -7 and 5, -6 and 0, -5 and -3, -4 and -4, -3 and -3, -2 and 0, -1 and 5. Let's look at how this graph is going to look. Alright, -7, 5 means I'm going to go to the left 7, 1, 2, 3, 4, 5, 6, 7, and I'm going to go up 5, 1, 2, 3, 4, 5. -6, 0, 1, 2, 3, 4, 5, 6, 0 means we stay. Then -5, -3, we go down 3, then we go down 4, and then it starts all repeating. This is what our graph of x squared plus 8x plus 12 would look like. Alrighty. So that's all they wanted us to do. We just wanted to practice graphing it. Now, today we are going to be able to find zeros of a quadratic function graphically and use the zero product rule by factoring. So, what does this mean? X-intercepts zeros, roots, and solutions of a quadratic equation are almost all the same thing. Essentially, they are all where the function crosses the x-axis. And we know that in order to be on the x-axis, that is when y equals 0, because we don't go up, we don't go down. So the only difference that we would see with these are, normally with an x-intercept, you would see your answer as a point. So whatever the x value is, and then 0 for the y. But normally when you have zeros, roots, or solutions, you just write the answer as x equals whatever the number is. Alright, so how many numbers of real solutions can we have? With any quadratic equation, we can have either no answers, one answer, or two answers. This all depends on how many times the graph hits the x-axis. So if the graph only goes through the x-axis once, then that would be one solution, if it only hits it once. If it hits it twice, like that last example there, that would be two solutions. And if the graph is really above the x-axis or really below the x-axis, then it's never going to hit it, so we would say there are no solutions. There's no real solutions. Alright, so now how are we going to find these solutions graphically? We are going to take our graphic equation and put it into our calculator. This will allow us to see a picture of what it will look like. We're going to, sometimes we might have to zoom out or zoom in so we can see our graph better. And once we have a good picture, we are either going to count where the graph falls on the x-axis, or we can use the analyze button on our calculator to ask it to see what the zeros are. Alright, so what am I talking about? Let's look at this together. Alright, this is the question that we did in the do now. We graphed this already, and this is what it would look like. Now, if I want to find the zeros, I'm going to look on my x-axis, and I'm going to ask myself, where does it cross? It crosses right here at -6, and it crosses right here at -2. So a few different ways you can write your answer is, you can write that they are -6, 0, and -2, 0. We can say that our answers are x equals -6 and -2. Or another way is we can say that x equals, with these squiggly brackets, -6, -2. These are just some different ways on a multiple choice question that we can see our answers. All we're doing is graphing the quadratic equation and then seeing where does the graph cross the x-axis. Let's look at this next one. Graph the following quadratic equation and then identify the roots. Alright, so we have x squared minus 6x plus 9. Remember, if they ask us to graph to find the solutions, the zeros, the roots, the x-intercepts, those all mean the same thing. So now I'm going here on my table and seeing where is my y value between negative 10 and 10, which is right here, 0, 9, 1, 4, 2, 1, 3, 0, 4, 1, 5, 4, and 6, 9. And now I am going to graph these points. 0, 9 means just go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 4, you go up 4. 1, 2, 3, 4. 2, 1, you go up 1. 3, 0, you stay. And then because that was our x-intercept, everything else is going to start repeating. So it is going to look like this. Now, this would be a situation where we only have one value for our x-intercept, our roots, our solutions, whatever you're going to call it, because it only crosses one time. So it only crosses at 1, 2, 3. So we would say that our answer is either 3, 0, our answer is x equals 3, or our answer is x equals curly bracket 3. And those are the roots of our quadratic equation. So now sometimes we might not want to do it out using a calculator by graphing, because if it's a multiple choice question, we don't really need to do all of that. So another way that you can do it is we can type the question into a calculator, 4x squared plus 12x plus 9, okay? And now I'm going to come here to my calculator. I just need a normal picture of it. Alright, if we see, why does it look so weird? 1 second, guys. This thing got all messed up. It's not supposed to look like that. 1 second. Alright, so let's look back at it. Alright, this looks better. So I'm going to type in 4x squared plus 12x plus 9. And now this is a picture of our graph. So I know I'm going to have one answer. There's one time when it crosses the x-axis. But I'm going to actually use my Analyze button on my calculator. So I'm going to go to the menu part. And I'm going to be analyzing what my 0 is. So what you're going to do is, it says left bound. What that means is you're going to bring your thing somewhere to the left of what you're trying to find. And now somewhere to the right of what you're trying to find. And our zeros would be, what is that point? They don't give me a good job at telling me the exact point. I wish I could show you guys this on our calculators at school. 1 second, guys. I'm going to use the calculator we have from school, and I will let you know what answer we get. When you do that in the calculator at school, it will tell you that our answer is x equals 1 second, I'm doing it right now. We will get that x equals negative 3 over 2. So our calculator almost gave that to us. It was just giving us a little bit more. So that is our answer, or you could use the point negative 3 over 2, comma 0. All right, so for the next one, again, we are going to type this in. X squared minus 5x plus 7. X squared minus 5x plus 7. You are going to go to graph it. And now we want to analyze this point, so I'm going to go to find the 0 button. And now I go somewhere to the left of the 0 button that I'm trying to find, which is like right there. And now somewhere to the right of it, which is like right there. And it's telling me that it's probably 2.5. Let me just double check on our calculator here. We have x squared minus 5x plus 7. Alright, so we would get x equals we didn't even need to do all of that, because if we see here, our graph never ever crosses the x-axis, which means that we don't have any solutions here. No solutions. It never ever crosses the x-axis, so there are no solutions. Alright, let's look at these next two. Let's type, well, you should actually pause the video and try these two on your own. We have 2x squared minus x minus 15. I'm going to graph it. Let me make sure there's actually going to be answers here. Yes, there's going to be two answers. So let's find what these answers are going to be. Alright, let's go. If we look at the table and we look where does y equal 0, it equals right here at x equals 3. So we know that's going to be one of our answers. And the second answer that we could have, where's another place where it equals 3? Well, I'm not able to see the second one here, so let me do my analyze button. I'm trying to find my zeros. And I'm trying to find what is this negative answer over here. So I'm going to keep going until I see my thing. Alright, somewhere to the left of it is like over here. Somewhere to the right of it is like over here. So it's going to be negative 2.5, and x equals negative 2.5. Those are our two answers. And let's look at this problem right here. X squared minus 8x plus 16. If I go to graph this, I'm only going to have one answer. And my answer is going to be, let's see, analyze the 0 button. And we're going to go somewhere to the left of it. So like we could go right here and somewhere to the right of it. So our 0 is x equals 4. Only one answer. Alright. Now, sometimes we don't want to do this graphically. It's going to tell us to do it algebraically. So, when do you think using the graphing method to find zeros might not be the best? Sometimes it's not the best, first of all, when you're not given a graph. Because if you're not given a graph, I'm not going to want to sit here and make a whole graph on my own. And then it's also not good if we get like decimals and stuff, because then we can't just count on the graph. So, another method we can use is a method called the zero product law. This says if you have two or more quantities and they have a product equal to 0, then at least one of those things must be equal to 0. So, we can say A times B, whatever the first thing times the second thing, if that equals 0, then either A equals 0, B equals 0, or both things equal 0. And that is what we are going to deal with today. So, what are our steps for solving quadratics by factoring? Our first thing is going to be to make sure our equation is equal to 0. We might need to do some adding or subtracting to move around terms to get the quadratic equal to 0. Then we are going to factor the polynomial just like we learned. Maybe with the AC method, maybe with the difference of perfect square. Maybe we'll have to take out a greatest common factor. Then once we get our factors, we are going to set each of those factors equal to 0, and we will solve. Once we solve, we'll find an answer for x, and we will write our solution. So here, for this thing, this is just an easy example of, it's already factored for us. This problem started out something like x squared plus 5x minus 14. And then we had to factor it by finding what adds to 5 and what multiplies to negative 14. And we ended up with these two things. So now you're going to take each of these factors and equal them to 0. So instead of plus 7, you're going to subtract 7. So we would get x equals negative 7. Instead of negative 2, you're going to add 2. So we would get x equals positive 2. So these would be our two answers. You could also say x equals negative 7, comma 2. And let's look at the second one. This is already written for us. We are just going to have to set each of these equal to 0. Remember, first, tomorrow, you guys are going to see that we're going to actually have to solve these ourselves. We're going to actually have to factor them ourselves. So to get rid of the minus 1, we add 1. And to get rid of the 2, we have to divide. So our answer would be x equals 1/2. And this one, we're going to subtract 4. So we would get 3x equals negative 4. And then divide by 3. We get x equals negative 4 over 3. And these would be our two answers. Alright, and now some individual practice for you. Pause these videos, set them equal to 0, see what answers you get. we will have x minus 9 equals 0 and x plus 9 equals 0. Originally, this would look something like x squared minus 81. You know, to separate x squared, we could separate it into x and x. And to separate 81, we could separate it into 9 and 9. So for the first one, we're going to add 9 to both sides. We would get x equals 9. And for the second one, we would subtract 9 from both sides. We would get x equals negative 9. So our answers are x equals negative 9 and 9. And let's look at this one again. Set each of these things equal to 0. So for the first one, to get rid of minus 6, we're going to add 6 to both sides. So we get 4x equals 6. And to get rid of 4, we divide. If you typed it in your calculator, it would give you 3 over 2. And for this one, we're going to subtract 1 from both sides. We get negative 2x equals negative 1. And then we would divide by negative 2 to find out that x equals 1/2. And these are our two answers. Alright, so let's just summarize real quick. What are other names for x-intercepts? Their other names could be roots, solutions, or zeros. What would the picture of a graph look like if there's 0 solutions? That would mean you would have a graph that doesn't ever touch the x-intercept. For one solution, it would touch it once, and for 2 solutions, it would go through it twice. How do you find the zeros of the quadratics using the calculator? You could do the analyze 0 key, where then you have to do the left bound and the right and the lower bound, which is a little bit to the left of it, upper bound a little bit to the right of it, and then it should tell you your answer. When is solving algebraically better than graphically? That's whenever you have decimals, because you're not going to be able to sit there and count the spots. And how do you find the zeros of a quadratic equation using the zero product property? You factor and equal to 0, then solve. And that concludes our lesson on how we are going to find zeros of a quadratic function graphically and through using the zero product property.